So in this video we're going to have a little look at the extra bit that we need to add on to momentum and impulse, and that is the coefficient of restitution. Now the coefficient of restitution is pretty similar to the coefficient of friction in the way in which it works. Again, it's got absolutely no units, okay, so we've sort of put that one at the bottom there. There's two different ways that we're going to work it out as well. First of all, if we're looking at something colliding with a wall, obviously the velocity of the wall doesn't change, so all we're looking at is the change in velocity of the particle itself, whereas if we're looking at a collision between two particles, we're going to use this version of the formula. Up with the wall one, there's this very important point that we need to use only the magnitude. Okay, so don't put any sort of positive or negative signs on your velocities. You're actually going to treat them as a speed rather than a velocity in this case. And finally, for our two-particle formula, you do need to use signs. So you need to, again, as normal, pick a positive direction and then make sure you're using a velocity. The actual values of the coefficient themselves mean something, so we're just going to talk about that now. So first of all, if we consider our equation down here about two particles, sometimes the value of E will come out to be 0. And the only way that can happen is if V2 minus V1 is equal to 0. And for that to happen, these velocities have to be equal. Now thinking about it, if the two velocities are equal, that means the particles are moving at the same speed as each other. So immediately after the collision, then they're travelling together. And that means that they have coalesced. So that's our sort of key word for this, okay, so that means they've coalesced, and that just means joined together. Okay, sometimes exam questions will say to you to write down the coefficient. So if in the question it said that they've coalesced, then you'll be able to write down the coefficient of 0, or it might say to calculate it and then say what does this mean. If it's between 0 and 1, that's just a regular inelastic collision. So that's basically your standard collision where there's been some sort of change in movement, but they haven't necessarily joined together. And finally, if you've got a coefficient of 1, that means that it is a perfectly elastic collision. So that means there's been no kinetic energy lost at all, because in an elastic, you've got energy lost as heat, whereas in a perfectly inelastic collision, kinetic energy stays the same, so no energy has been lost. Okay, so those are the three main categories which you need to know. Let's have a look at using this now then. So we've got a sphere A of mass 2 kilograms travelling at a speed of 10 metres per second, and it collides with a sphere B of mass 1 kilogram travelling in the same direction at a speed of 4 metres per second. We're given the coefficient of restitution, so that's going to be a useful piece of information for us. So I'm just going to highlight that one, as well as some of the important data. So 0.4, let's make that a little darker. 0.4 is going to be important. There's another speed, a mass, and a speed. Okay, so we've got to find the velocities of spheres A and B after the collision. Right, so let's draw a little sketch. So we've got 2 kilograms going at a speed of 10, and it hits into sphere B, which has got 1 kilogram mass, and it's got a speed of 4. And afterwards then we've got VA and VB. Okay, so we could use conservation of momentum. So we know that 10 times 2 plus 4 times 1, of course we've picked a positive direction, I've picked it to be this way, and that's equal to 2 lots of VA plus 1 lot of VB. Okay, we've got two unknowns in that, so we're thinking simultaneous equations, we're going to have to find another one. So our second equation comes from the coefficient of restitution. So this time we're going to do our V2 minus V1. So VB, which we don't know, so VB minus VA equals minus E, and E we know is 0.4 because it told us the coefficient of restitution in the question. And then we've got U2 minus U1, so 4 subtract 10. So I can now rewrite that as VB minus VA, and then actually calculate it. So 4 minus 10 is minus 6, so it's going to be equal to minus 2.4. And there's my equation 2. To make life a little bit easier for us, I'm just going to switch sides on everything, because in equation 1 I had VA and VB on the right. So I'm just going to completely move everything over, so I'm going to have 2.4 on the left becoming positive, and on the right I'm going to have VA minus VB instead. Okay, so actually I'm going to call that equation 2 instead of my original one. Okay, now we're ready to solve simultaneously. So 1 plus 2, that's going to give me, so 10 times 2 is 20, plus 4 times 1, so we've got 24, plus 2.4 on the left, and then 2VA plus VA gives us 3VA, and VB plus minus VB cancels out, so that's going to help. So I'm ready straight away to find VA. 24 plus 2.4, get that and divide it by 3. That gives me 8.8 meters per second. And then all I'm going to do is substitute it back into the equation. I'll probably pick equation number 2. I think this one might be easier. So VB is going to be VA minus the 2.4 if we rearrange that. So that's going to give us 6.4 meters per second. Okay, all done. Right, so we've got a two-part question here, so we're just going to focus on part A to begin with. We've got an object A of mass 3 kilograms and it's moving with a speed of 7 and it collides directly with something else, 5 kilograms, 3 meters per second. The important thing here is that that's going in the opposite direction. Okay, then we're told that after the collision, B reverses direction and the speed is 2.4. Okay, so this time we're calculating the coefficient, so we'll have a look at our sketch first. Okay, so we've got a 3 kilogram and a 5 kilogram particle. The 3 is moving with 7 and the 5 is moving by 3, and remembering that we know that it was in that opposite direction. And then the direction of B is reversed, so B is now going to be going this way with a speed of 2.4, and we don't know the velocity of this one. I'm going to guess that it's in the right hand direction, but we can always find that out later if required. I'm going to pick this way as positive. Right, so I'm calculating the coefficient of restitution between A and B. So looking at my formula for the coefficient of restitution, I need to find E, which means that I should know everything else that's in there. Unfortunately, I don't yet know the final velocity of particle A, so I'm going to have to work that out first. And I'm going to use my conservation of momentum to do that. So 7 times 3 plus 5 times minus 3 is 3 lots of V plus 5 times 2.4. And we'll do a bit of rearranging there. And that gives me a velocity of minus 6 meters per second. Okay, so what I've learnt from that is that actually it's going to rebound in the opposite direction. Now that I've got that, I can start calculating the coefficient of restitution. So I now know the velocity, so let's sort of add that on the top. So red arrow going that way, and that's going to have a velocity of 6. So using that, V2, 2.4, again I've chosen my positive direction to the right, and then I'm going to subtract the velocity of the first particle. So that's actually got a velocity of minus 6. And that equals minus E, brackets, the second initial velocity, that's minus 3, and I'm going to subtract the 7 there. Okay, let's tidy this up before we put it in the calculator. We've got 2.4 plus 6 equals minus E times minus 10. So 2.4 plus 6 divided by minus 10 tells us that minus E equals minus 0.84. and therefore E must equal 0.84. And there's our coefficient. No units, of course. Okay, on to part B then. So it says after the collision between A and B, object B then goes on to collide with a wall. So initially we know that B was travelling at 2.4 after the collision with A and B, and just to remind ourselves it had a mass of 5. It then hits a wall. Okay, and this fact that it's perpendicular to the direction of motion just means that we're allowed to use this formula. This formula is only applicable if the two particles are sort of hitting with a perpendicular direction. So there we go. We're going to have an inbound speed and then we're going to have an outbound speed. We're also told that the coefficient is 0.6. Okay, that's given to us in the question as well, and we're using that 2.4 from before. Right, ready to calculate then. So E minus 0.6, let's make that better, 0.6 equals the final velocity, which we don't know, over the initial velocity. So then we can just rearrange that. 0.6 times 2.4 gives us 1.44 meters per second. A good thing to always check is that the final velocity after something's collided with a wall can never be faster than the speed that it had in the first place. So we have at least got that. So in the lesson I'll ask you a few multiple choice questions, and I thought you might like to prepare for these now. So first of all, we've got, if the coefficient of restitution is calculated to be 0, what does this tell you? And so then you've got your options down here that you'll have to choose from. Then, when do you use velocity as opposed to speed when you're calculating the coefficient of restitution? Think back to the very first sort of slide that we went through for that one. And then we've got a nice long question here, and I want you to try and think about how you're going to solve it. Like, have you got simultaneous equations? Do you just have to do one thing first, etc.?